This is Ms. Black with Open Campus. This is Math 102, and we are now in Module 3, Part B. So the last time I spoke with you guys and gals, we were talking about this new number, an imaginary number. And we realized it comes from the fact that you cannot square root a negative number. For example, we know the square root of 9 is 3, and that's because 3 times 3 is 9. But if I asked you the square root of negative 9, you wouldn't have an answer for that, because 3 times 3 is positive 9. Negative 3 times negative 3 is also positive 9. So we learned a square root of a negative number doesn't exist in our real land. So mathematicians made up a new land called imaginary numbers, and we say the square root of negative 9 is 3i. And we use that I to represent it's imaginary. What the great thing that happened is when mathematicians came up with this new number, an imaginary number, they realized you could do the same operations with imaginary numbers that you could do with real numbers. So think about your math history. In all these years, you have learned to add, subtract, multiply, and divide any real number, whether it's positive or negative whole, whether it's a fraction, a decimal, or a mixed number. So what we're going to do today in this module is actually learn how to add, subtract, multiply, and divide imaginary numbers and real numbers together. And when you put them together, that's our new vocabulary word, complex number. So if you please go to your class notes, let's discuss what a complex number is. Okay, so if you look at the notes, the PowerPoint, we have a definition of a complex number. It's a number written in the form a plus bi, where a and b are real numbers. So, for example, if you look down there, 7 minus 2i is a complex number. It technically has two parts. It has a real number part, 7, because we all know 7 is on our number line. It also has an imaginary number, negative 2i, and we know that's imaginary because it has the I, the symbol for imaginary. So when we put a real number and an imaginary number together, that's called complex. And we always write the real number first and then the imaginary number second. That's just proper form of writing a complex number. So if you look at my second example, 4i. This is a complex number. Now you're probably thinking, well, wait a minute. I see the imaginary part, 4i. Where is the real part? Well, we got to go back to basic definitions from elementary school. What real number can you add to anything that will keep it the same? And we all know that's the real number 0. So 4i, which is a complex number, really means and can be rewritten as 0 plus 4i. So we see 0, the real part, and 4i, the imaginary part. Now, what we're going to do through this module is we're going to go over the 4 operations. We are going to learn how to add, subtract, multiply, and divide complex numbers. This directly relates to what you've learned in arithmetic and algebra. You can only add things that are alike. So if you think back to algebra, if I have an x and a letter y, can I add that? No, I cannot. They're not like terms. But if I have an x and a 2x, can I add that? Sure I can. That makes 3x. So when we take our complex numbers, which have a real part and an imaginary part, just remember, you can only add the terms that are alike. So you're going to have to add or subtract the real number with the real number, and then you're going to have to add or subtract the imaginary number with the imaginary number. When we get to multiply, I want you to think of the I like the letter X. So if you go back to Algebra 099, and you remember we learned how to multiply. When we do X times X, multiplying means it's going to get bigger. And we learned in Algebra 2, when you multiply variables, letters, you add exponents. So we learned in Algebra 2, X times X is X squared. Well, the same thing is going to be also true with I's. I's, even though they stand for a square root of a negative number, they are still a variable. And those rules of multiplying and dividing variables still hold true. So when we multiply I's, we're still going to add the exponents. And when we divide the letter I, we're going to do the opposite and subtract the exponents. So when we do these 4 operations, even though we're using a different variable I want you to relate it to Algebra 2 and think about your variable x. And we knew in algebra you could only add like terms, the like variables. And we learned when you multiply variables, you add exponents. And when you divide variables, you subtract exponents. So let's go to the whiteboard and try this. So, everybody, here we go. Now I want you to pay careful note that there are no equal signs here. We are not dealing with today equations. So I am not asking you like in Module 1 and 2 to solve, because these are not equations. Your job is not to isolate a variable if it's not an equation. These are algebra expressions. Okay? If you don't have an equation, then the other, what we call it in algebra, is an expression. What you do with expressions is you simplify them. Simplify is a fancy word that means do whatever operation you see. Follow the rules of please excuse my dear Aunt Sally. Now I know you've all heard that before. Please excuse my dear Aunt Sally. That's a cute little phrase to remember what operation you do first and what order to do the others. So I'm going to write that on the board. Please excuse my dear Aunt Sally. P means parentheses, but P does not mean parentheses. It means to work whatever is inside a symbol. So if you have parentheses, you work the inside. If you had a bracket, you'd work what's on the inside. If you had absolute value, you'd work on the inside. If you had a square root, you'd work on the inside. You always want inside a symbol one number. So you always do that first. E means exponent. If there's an exponent, that goes next. M is multiply and D is divide. Now this is important. You should have learned mom is not better than dad. M is multiply, D is divide. But that does not mean you do multiply first and then divide. You do them in the order you see them, left to right, because these are equal operations, just like mom and dad should be equal. A stands for add, S stands for subtract. Again, you don't always do adding first and then subtracting. They are equal. So you do them in order as you see them, left to right. So what's important is parentheses goes first, what's inside a parenthesis or a grouping symbol. Then you do an exponent, then you do multiply, divide. The last thing you do is add and subtract. So we're going to follow order of operations and work all these expressions. And what you're going to find out today is we'll be working with real numbers and imaginary numbers. So our first example, it says square root of negative 64 plus square root of negative 49. Well, you already learned you can only add things that are alike. I can't add right now because what's inside these radicals is not alike. But wait a minute, what did we learn in the first module of 3? We learned if you're taking a square root of a negative number, this answer is imaginary. So first thing we're going to do is we're going to follow, please excuse my dear Aunt Sally. We're going to do what's inside the symbol first. We know the square root of 64 is 8. So the square root of negative 64 is 8i, because it's imaginary. Bring down the plus. We know the square root of positive 49 would be 7. So the square root of negative 49 is 7i. It's imaginary. Now look here. I want to add 8i to 7i. Are they alike? Well, sure they are. That's just like in algebra adding 8x to 7x. If they're alike, you put them together. So if I have 8i and you have 7i, we have together 15i. Because remember, when you add, the thing that's the same, the term that's the same, stays that way. If you added 8x and 7x, it would stay 15x. That is a complex number. It has a real part, it's understood to be 0, and then the imaginary part, 15i. And that's how the answer should be written in A plus BI form. I should see the real part and the imaginary part. Okay, example 2. It's not an equation. There's no equals. So you're going to follow order of operations. P means to do whatever inside a symbol first. So we're going to work inside here first, which means the 5 stays where it is. We know the square root of 16 would be 4, so the square root of negative 16 is 4i. And everybody look closely. This 5 and the square root are side by side kissing each other. That's connected by multiplication. That's why I'm putting it in parentheses. We're going to bring down the minus 3 because here's our next grouping symbol. So again, I know the square root of 144 is 12, but because it's negative, it's imaginary, 12i. And again, this number and this symbol are side by side kissing. That's connected by multiplication. So I did the P. Now I do not have any exponents, so the next is, do I have multiply or divide? I sure do. I have multiply. 5 times 4i is the same thing as 5 times 4x. 5 times 4 is 20 with an I. Negative 3 times 12i is negative 36 with an I. Now when you read that says 20i minus 36i, it said subtract. The sign, we have like terms. The signs are different, so we subtract and we get negative 16i. So to write that as a complex number, the real part is an invisible 0. There's no real number here. Minus 16i. See how easy that is? Think of the I just like the variable x. When we add x's, we don't change the letter. So when we add i's, we keep the letter. All right, go to example 3. This one says 7 plus 2i plus 1 minus 4i. So obviously you heard me say the operation addition. But you can't add with terms and symbols. So we know parentheses means to multiply. Well, to multiply, we got to look on the outside. What's on the outside of this parentheses? That's correct. There's an invisible 1. Well, 1 times 7 is 7. 1 times 2i is 2i. Now, do you need to write the 1? No, but it's understood to be there. That's why you're dropping the parentheses, because you're really multiplying by 1. Same thing here. Here's a parenthesis. To get rid of it, I have to multiply. That's what parentheses means in math, multiply. If I put that 1 in front, 1 times 1 is 1. 1 times negative 4i is negative 4i. Now we're not done. I have 1, 2, 3, 4 terms I'm supposed to put together who's alike. If you look closely, you have 2 numbers that are real. 7 plus 1, that makes 8. Then you have your imaginary numbers. 2i minus 4i is negative 2i. And that would be your answer. Every answer has to be written in A plus BI form. A real number and imaginary. A real and imaginary. A real and imaginary. Let's go to the next one. This doesn't say add, this says subtract. So again, to add or subtract, you cannot have your terms stuck in symbols. So we have to get rid of the parentheses. There's nothing you can do inside because you can't add a 7 to a 2i. They're not alike. So that's why we get rid of it. We're using the distributed property. So we're multiplying through by 1, which you really don't have to show me. But I just want you to understand that's why you're getting rid of the parentheses. You're saying 1 times 7 is 7. 1 times 2i is 2i. But if you look here, in front of this parentheses is not any 1. It's a negative 1. And we have talked about this over and over again. Multiplying or dividing by a negative 1 changes signs. So you can think of this as being a negative 1 here and distributing it. You could also think of it as being subtraction, and the definition of subtract means to do the opposite. And the doing the opposite of subtraction is addition. So I always taught my class when you see a subtraction sign, you change it to addition, and everything behind becomes the opposite, or the additive inverse. What's the opposite of 1? Negative 1. What's the opposite of negative 4i? Positive 4i. That's the same thing as distributing a negative 1. A negative times a positive is a negative. A negative times a negative is a positive. So no matter how you look at it, guys, I'm subtracting, I change what's behind, or I see a negative 1 and I distribute it, The signs are going to change. Now you got to collect like terms. So our real number is 7 and a negative 1, which makes a 6. And our imaginary is 2i plus 4i, which is positive 6i. And yes, that answer is in a plus bi form. The real part, the imaginary part. So far, so good? All right, let's continue on in our notes. I know we have quite a few more examples to look at. All we're trying to do today is review what you learned in algebra. Instead of using x, we're using I. So here's example 5. It says 3i, 7 minus 9i. So what operation is that? Very good. That's multiplication. Again, you can't do what's inside. A 7 and a minus 9i are not alike. That's real, that's imaginary. You can't put that together. So the only way to get rid of the parentheses is to multiply. What do you call this when I multiply like that? When I give it to everybody? Good. It's called the distributive property. All right. 3i times 7, 21i. 3 times 7 is 21, and you need the I. Now pay attention. We're going to multiply 3i times negative 9i. 3 times negative 9 is negative 27. I times I is the same thing as x times x. So you learned in basic algebra, when you multiply variables, you add the exponents. There's an invisible exponent on the 1 here. There's an invisible exponent on the 1 here. So I times I is always going to be I squared. Now, we have a problem. The homework, the directions say to write your answer in A plus B I form. A real number and an imaginary number. An imaginary number just has I to the first power. Look here. There's your BI. That says I squared. When you write your final answer, you cannot have an I squared. All you can have is an I. So now we got to learn, what does I squared mean? Okay? Well, we're going to go back to basics. How did we even get this I squared? Well, we got this I squared because we multiplied I times I. Now, in the module from the other day, we learned the definition of I. I stands for an imaginary number because it stands for the square root of negative 1. So really what you're saying is I squared is the square root of negative 1 times the square root of negative 1. So if you guys know how to multiply these two square roots together, you'll know what I squared is. So to know how to multiply those square roots, let's go back to good old arithmetic and algebra. Let's try something. Let's see if we notice a pattern. If I asked you to do square root of 2 times square root of 2, you would multiply what's on the inside, which is 2 times 2, which is 4. But it's in a square root symbol. And what is the square root of 4? Yeah, it's 2. Let's try another one. If I asked you to multiply the square root of 3 times the square root of 3, well, we'd multiply 3 times 3, which is 9, but we leave it inside that square root symbol. But what is the square root of 9? Yeah, that's a perfect square. That's 3. Do you see a pattern? Let's try another one. Let's try square root of 7 times square root of 7. Well, 7 times 7 is 49, but it's under a square root symbol. What is the square root of 49? Yeah, it's 7. So what you should notice is a pattern. Every time you take a square root and multiply it to itself, you really don't have to do this middle step, because the square root of 2 times the square root of 2 is just the number 2. A square root of 3 times the square root of 3 is just the number 3. A square root of 7 times the square root of 7 is just the number 7. So if you understand this pattern, if I said square root of 10 times square root of 10, what should you just say? You should just say the number 10, because a square root times itself is just that number. So now go over here. We have I squared. Well, it's a square root of negative 1 times the square root of negative 1. Do you see that's the same number just like these all are? So the answer is just going to be negative 1, the number inside. So everybody look at this closely because you need to memorize that. A I squared is not really imaginary. Every time you see an I squared, you can replace it, substitute it, exchange it for this number, -1, which is on our number line. That's a real number. So what you got to understand is when you're working with imaginary numbers, you should never, ever, ever leave an I squared. Every time you see an I squared, you're going to replace it, exchange it, substitute it with the number -1. So we're not done here. We're going to leave the 21I minus 27. But we're going to replace this I squared with the number -1. And because it's side by side, it's connected by multiplication. Now everybody look. We're going to do multiplication. What's a negative times a negative? Yeah, that's positive 27. That's your real number. That goes in front. This right here is your imaginary number plus 21I. So remember, in imaginary land, the real number has to go first, followed by the imaginary. You'll know it's imaginary because it has the I. No answer should ever have an I squared. You should always replace I squared with -1. So you need to memorize that fact. Okay? Let's try another one. Example 6 in our notes. 3 plus I times 3 minus I. So we're connected by multiplication. We have two parentheses, side by side, connected by multiplication. All righty? We know to multiply a binomial 2 terms times a binomial 2 terms is the FOIL method. And FOIL is a cute way to remember how to distribute. If you're good with your algebra skills, you should remember FOIL stands for first, outer, inner, last. Okay, I've already showed this to you. I'm going to show it to you again. The way I remember FOIL is if you put some eyeballs above the plus and minus. If you do FOIL correctly, you should make a little smiley face. The first term is who's first in the parentheses. So the first term is 3 times 3, which is 9. The outer term is who's on the outside, which is 3 times a -I. So the outer is 3 times -I, which is -3I. The inner term, inner is what's on the inside. It's positive I times 3, which is positive 3I. And L is the last term, which is usually who's last here. That's positive I times -I. Now remember, we're multiplying. A positive times a negative is a negative, and I times I till the day you die is I squared. So you all know when you do FOIL, because FOIL has 4 letters, you should get 4 terms. Okay? Now some people didn't call it FOIL, they just called it double distributing, which is fine. We're all doing the same thing. What you should realize is after the parentheses are gone, you're no longer multiplying. You're adding and subtracting. So you're looking for things that are alike. Well, usually the terms in the middle are the ones that are alike. So we're going to collect them. So we're going to leave the 9, -3I plus positive 3I. Now we're putting these together. If I lost 3 and then got 3, or if I had 3 and then lost 3, I'd have nothing. -3 plus positive 3 is 0. We don't need to write 0I. There's nothing there. And I bring down the minus I squared. But I can't have that as my final answer. My answer has to be in A plus BI form. I can't have an I squared. I can only have an I. So what I need to do is replace this I squared with the number -1. So now watch, because here's where the boo-boos come. You bring down the 9. You bring down this subtraction. You are replacing this letter I squared with -1. 9 minus a -1 is really 9 plus 1, which is 10. Now everybody look. That's a real number 10. So to write that in A plus BI form, I would write 10 plus 0I. There is no imaginary part to it. Is everybody okay with that? Now, if you had a good algebra teacher, you should have remembered sometimes when we're doing FOIL, you can cheat. These binomials are not just any binomials, they are called conjugates. Have you heard that word before? I would hope so. A conjugate is when you have a binomial that has the same terms. It has a 3, it has a 3. It has an I, it has an I. And you only change the middle symbol. Well, what happens is when you multiply conjugates, you really don't need to do first, outer, inner, last. Because what happens is the 2 in the middle here, the outers and the inners, crossed out, canceled. So we learned back in algebra a trick. To multiply conjugates, you just do the first and the last. So if I did that quickly, 3 times 3, the first would be 9. I times negative I would be the negative I squared. And I would have the 9 minus I squared without all that extra work. So there's a little trick in case you didn't know it. All right, let's try example 7. Okay, so 7 in your notes says 3 plus 7i squared. So we're supposed to follow order of operations. So here we go. What does squaring mean? Squaring means to multiply it by itself. So yes, you should remember you must write this out twice. Because once you write it out twice, you'll realize, oh, it's a binomial times a binomial. I have to do the FOIL method, or I have to double distribute. I call it FOIL because it's a cute way to remember it. I like to put my eyeballs so I can make my little smiley guy. So FOIL stands for first, outer, inner, last. Who is first here? Good. It's 3 times 3, which is 9. Who is outer? 3 times 7i, which is 21i. Who are my inners? 7i times 3, which is also 21i. Who is my last? 7i times 7i. Well, 7 times 7 is positive 49. I times I is I squared. So if you look, you made a little smiley guy. The first and the last are his eyebrows. Outer is his mouth. Inner is his nose. So that always helped me visually. Now if you look, when we do FOIL, we get 4 terms. Now there's no more parentheses, so we put together what's alike. These are alike. So we leave the 9. 21i plus 21i is 42i. Bring down the plus, 49. But wait a minute, I can't keep an I squared. What are we always going to exchange an I squared with? We're going to substitute in the number -1. They're side by side, so they are connected by multiplication. That's why we put a parentheses. So now we got to work this. We got to work multiplication before we do anything else. So we have 9 plus 42i, and a positive times a negative is a negative. Are we done, or can we continue? Sure we can. We have like terms. There's a number, a real number, there's a number. So 9 minus 49 is -40. Then there's your imaginary number, 42i. Put it together, it's called complex. So that is your answer. All right, we have a couple more. All right, example 8. Let's see what you can do. You have 3 minus square root of -5, parentheses, 4 plus square root of -5. So what operation are you doing? Are you adding, subtracting, multiplying, or dividing? If you look closely, we're multiplying. 2 parentheses kissing each other is multiplication. There are 2 terms here. There are 2 terms here. It's a binomial. But wait a minute. If we're following order of operations, aren't we supposed to do what's inside a symbol first? And inside your symbol, you have a square root of -5. And from the module 3a, we learned a square root of a negative number is not real. It's what? It's imaginary. So we have to do that first. So what we're going to do is we're going to bring down the 3 minus. We know we have a square root of a negative number, so we need to pull that I out. But can you break down square root of 5? No. 5 is not a perfect square. There is no perfect square in 5. So poor 5 has to stay inside the square root symbol. So now we go do the here. We put our parentheses right, 4 plus. I have a square root of negative 5. Well, wait a minute. I can't have a square root of a negative. Square root of a negative is imaginary. That's why we bring the I out. We're getting rid of that negative by saying the answer is imaginary. And then can you break down a square root of 5? No, you cannot. So it stays inside. So now we have our two terms are binomial. Our two terms are binomial. We're back to doing FOIL. Okay, that's my cute little name. So here we go. We're going to do first. If you want, put your eyeballs in. And here we go. First, 3 times 4. That's 12. Outers is his mouth. 3 times positive I square root of 5. We've already discussed this. If it's on the outside, it stays on the outside. The positive's out there, the I's out there, the 3's out there. So when you multiply that all together, you would get positive 3I. The square root of 5 stays on the inside. All right, we're going to do the inners. Again, you have a negative I and a 4 on the outside. Negative I times 4 is negative 4I. And then the square root of 5 stays on the inside. Last would be his other eyebrow. Now be careful. Look what's on the outside. You're doing negative I times positive I. That doesn't make 0. A negative times a positive is a negative. I times I is I squared. On the inside is square root of 5 times square root of 5, which is square root of 25. So that's what FOIL looks like with your 4 terms. So far, so good? Now, the problem is we got to put together what's alike. When you do FOIL, it's usually these terms in the middle that are alike. They are alike. They both have a square root of 5. So if I have 3I and you minus 4I, well, 3 minus 4 is negative 1. So 3I minus 4I is negative 1I. So what happens is we bring down the 12. This is going to make a negative 1I square root of 5. We have minus, but wait a minute. What do we learn about I squared? Very good. I squared is negative 1. What do we know about the square root of 25? Very good. That's the number 5. So right here, you bring down the minus. I squared gets replaced with negative 1. And we know the square root of 25 is 5. Now if you look, these numbers are connected by multiplication. So now I have 12 minus 1I square root of 5. Well, we all know a negative times a negative is a positive. 1 times 5 is 5. Are we done? Nope, we got one more step. Here's our real numbers. 12 plus 5. That gives us 17. And then our imaginary number would be here because it has the I. Do we need to write a 1 in front of an I? Do we need that coefficient? No, we do not. So we could write negative I square root of 5. That is in A plus BI form. I see the real number. I see the imaginary. That's why this is called complex. Okay, let's keep moving. All right, our next example. Ooh, now we're doing a different operation. Look at 9. We have negative 10 plus square root of negative 125 over 5. Okay, look at that closely. If you look, I'm doing several operations. I see addition, I see division, I see a square root. Which one do you do first? That's right, you do the root first. So we're going to leave negative 10 plus, we're going to come over here. We know a square root of a negative number is imaginary. We're going to pull out the I. But what do we talk about with the square root of 125? You're right, it's not a perfect square. But that means you got to reduce it or break it down. So what perfect square divides into or factors into 125? Very good. This would be 25 times 5. And we know the square root of 25, that's 5. Can you do anything with a square root of 5? No. So this is important. We know the square root is a negative, so we're going to have an imaginary, an I. We know the square root of 125 is 5 square root of 5. This is all going to be connected by multiplication. So do we write I5? No, we write 5I square root of 5. So all I did was follow, please excuse my dear Aunt Sally, I did what's up here first, I broke down the root. Now, we know that this bar means division. You're dividing both of these pieces by 5. So technically, you could break this up into 2 parts. And now we can divide. Negative 10 divided by 5 is negative 2. Plus, well, 5 divided by 5 is 1. It cancels out. So that leaves us with I square root of 5. Look at that. There's your complex number, your real part and your imaginary part. All right, we only got a couple more. All right, let's go to example 10. This one looks relatively very simple. It is 9 divided by I. Okay, you're probably thinking, wow, that's a trick question. You're right, you can't do that, right? Think about algebra. Can you divide 9 by the letter X? No. The problem here is we can't leave this as the answer. I stands for the square root of negative 1. And if you go back to your algebra class, let's think back to algebra and arithmetic. Can you leave 9 over, say, the square root of 2? You should all know that that's an unacceptable answer. And it's unacceptable because anytime you leave an answer, that's a fraction. And this is a fraction. Here's the bar. There's your numerator. There's your denominator. Anytime you write a fraction from 3rd grade, the denominator always has to be a positive whole number. Now, why is that? Think about what you're saying here. You're saying start with something and divide it into this many groups. Think about it, guys. I have 9 people in my room. Can I ask them to divide into one group? Sure. 9 divided by 1 is 9. Can I take those 9 people and divide them into 2 groups? Sure. It would be 4.5, 4.5. Can I take those 9 people and divide them into 3 groups? Sure I can. That would be 3. But could I ask my class to get up 9 people and divide into square root of 2 groups? You can't do that. The concept is this bar means division. Anything in the denominator has to be a whole number. This is not a whole number. So back in algebra, you learned a little trick. You learned how to make this a whole number. Now, the trick you learned goes back to 3rd grade math. It has to go back to something called equivalent fractions. If you know your good arithmetic, think about this. What fraction is equivalent to 1/2? Well, isn't it 2/4? Equivalent means they may not look the same, but they have the same meaning. But is this the only fraction that's equivalent to 1/2? Nope. There's 3/6, there's 4/8, ... It can go on forever and ever. We learned in 3rd grade to make 1/2 become to 2/4, you multiply the numerator by 2 and the denominator by 2. To make 1/2 become 3/6, you multiply the numerator by 3 and the denominator by 3. So this concept of equivalence you've known since you've been little. Think about being a kid and getting money. Does it matter if you got a dollar bill or 4 quarters? No, they don't look the same, but they have the same meaning. They're equivalent. Well, that's what we're going to do here. From algebra, you should have learned if you write a fraction and this is not a whole number, you are going to have to multiply by something to make it a whole number. Well, that's the same concept here. You can never, ever, ever leave an I in the denominator. And I is not a positive whole number. Do you understand me? I stands for square root of negative 1. That is not positive, it is not whole. So we can never leave an I in the denominator. So to get it out of there, you're going to multiply. You're going to make an equivalent fraction. What can you multiply to I that's going to turn it into a number? Very good. You're going to multiply it by another I. And if you do it to the bottom, to keep balance, you got to do it to the top. This step here, this multiplying step, in algebra we give a fancy name. We call it rationalizing. They like to throw those fancy words in college math. Rationalizing just means make me an equal fraction, an equivalent fraction. That's all it means. So watch what happens. 9 times I is 9i. There's your numerator. I times I is I squared. Now I know what you're thinking. But Ms. Black, that I is still there. But now it's I squared. And what did you just learn I squared stands for? That's right. You just learned I squared stands for the number -1. So now you have 9i over -1, which you can't leave that. We know a negative floats to the top. And do I really need to leave a denominator of 1? No, because anything divided by a 1 is itself. So that just comes out to be -9i. And it's no longer a fraction. So it's very, very important that what we did on the board right now relates to 3rd grade math. It relates to what a fraction is. A fraction has a number in the numerator and a number in the denominator. But because the denominator means what you're dividing by, the denominator should always be a whole number. And if it isn't, we have to make an equivalent. We have to rationalize. All right, I think we have 2 more. So let's try another one and see how we do. All right, so let's look at our example 11. So the math is not hard if you understand why you're doing it. So look at 11. You have 2 over 3 minus I. So let's look at those operations. I see division and I see subtraction. Well, can we subtract the 3 from an I? No, we cannot. Can we physically divide the number 2 by 3 minus I? No, we cannot. So you can't do any of those operations you see. But you can't leave this because if you have a fraction and here's the division bar, underneath in the denominator can only be a positive whole number. Well, I'm sorry, this is not a positive whole number. You have a real and imaginary part. That's not allowed. So what we're going to do is we're going to rationalize. I know that's a fancy word. All that means is we're going to multiply. So now, here's the problem. What are you going to multiply 3 minus I that is going to guarantee the I is going to go away and you're going to get a whole number? Well, it takes us back where we started today. This is a binomial. To multiply it, I need another binomial. I don't multiply by the same thing, I multiply by the conjugate. And the conjugate of 3 minus I is 3 plus I, changing the middle symbol. And if I do it to the bottom, I do it to the top to keep balance. So now we're going to multiply. You've heard me sing before. Multiplying fractions is no problem. Top times top, bottom times bottom. So we're going to multiply. How do you multiply a monomial to a binomial? You distribute. So if you need to keep the parentheses so you can see the 2's in front and you're distributing, that's fine. 2 times 3 is 6. 2 times positive I is positive 2I. Because these binomials have a name, they're called conjugates, I am not going to go through first, outer, inner, last. I'm not going to do the extra work. When you multiply conjugates, which you can only do when you have binomials that change the middle symbol, I'm going to do the first and the last. So if I do the first, 3 times 3 is 9. Negative I times positive I. Well, a negative times a positive is a negative. I times I is I squared. Now you're saying to me, I know what you're saying, Miss Black, there's still an I in the denominator. It's not an I anymore. It's an I squared. And what did you learn you can replace I squared with? Very good. This is really 9 minus, and I squared can get replaced, exchanged, substituted with -1. In the numerator, we have a good old I, and you can't do anything with that. So in the numerator, we got 6 plus 2I. They're not alike. You can't add them. That's not an I squared. You can't get rid of it. But in the denominator now, you got 9 minus -1, which is really 9 plus 1. So what's your denominator? It's 10. And this is over 6 plus 2I. So now we followed arithmetic. The denominator is a positive whole number. I could ask you to divide something in 10 pieces. But wait, this is still unacceptable. This is not in a plus bi form. To be a complex number, I need to see the real part and see the imaginary part. So I need it split. So guys, look, divide by 10 means to divide both of these terms by 10. So we have 6 over 10 plus 2i over 10. Now, 6 over 10 is a fraction. That reduces. If we divide by 2, we'll get 3/5. There's our real part. 2/10 is a fraction. 2 over 10, if you divide by 2, you would get 1/5. And they want the I not to stay in the numerator. They want it on the side. They want to see the real and then the imaginary. So that would be your answer. So all we're really doing is taking these concepts from 3rd grade and using them in algebra. All right, we got one more example. Let's try it. All right, last example, guys and gals. 2 plus 3i divided by 2 plus i. Now you're going to say to me, oh, this is easy. We're going to divide the 2 with the 2. We're going to divide the I with the I. No, we're not. Your basic rule is you can only divide when everybody is connected by multiplication. Again, I didn't make that rule up. It comes from arithmetic. If I came over here and I said, do 4 plus 5 divided by 2. Go back to arithmetic. Well, we know 4 plus 5 is 9. 9 divided by 2 would be 4.5. So look at me. If you decided to divide first, you would not get the same answer. So if you looked at this and said, I'm going to divide 4 and 2, and you put a 2 there, 2 plus 5 is what? That's 7. That's not 4.5. So you learned a basic rule. You cannot divide when you're connected with add and subtract. It doesn't work. So we can't do the dividing. We can't add. Neither one of these are alike. There is no I squared up there, so we just can't get rid of an I. So the problem is your denominator a whole number? No, it's 2 plus I. I is not a whole number. I stands for a square root of a negative number. That is not a positive whole number. So we can't leave 2 plus I in the denominator. So we're going to have to make an equivalent fraction. We're going to have to do this new word, rationalize. That's a fancy word that means make me a new fraction. That's equal. And the way you make new fractions is you go back to 3rd grade, you multiply. What do we multiply to 2 plus I that's going to guarantee to make it a number? You're going to use its conjugate, which is 2 minus I. And if you do it to the denominator, you do it to the numerator. Now we're multiplying. The rule still goes. Multiplying fractions is no problem. Top times top, bottom times bottom. We're going to multiply this binomial 2 terms times this binomial 2 terms. Now everybody look closely. These are not conjugates. Even though this symbol's a positive and this symbol's a negative, they're not the same terms. They have the 2, but this term at the end is not the same. This is a 3i, and that's just an I. So these are not conjugates. Down here are conjugates. These 2 terms are like changing the middle symbol. So in the bottom, because these are conjugates, we could do first and last. But in the numerator, we're going to have to do all of FOIL. They're not conjugates. And the only way to multiply binomials is doing FOIL. So here we go. First, 2 times 2 is 4. Outers, 2 times negative I, negative 2i. Inners, 3i times 2. Positive 3i times 2 is positive 6i. Last, positive 3i times negative I. A positive times a negative is a negative. 3i times I is 3i squared. So that's the numerator multiplied out. Now we're going to do the denominator. Because we know that these binomials are conjugates, and you'll only use this word conjugate with binomials. 2 terms, 2 terms. Everything's alike except for the middle symbol. We're going to cheat. We're going to do first 2 times 2. We're going to get 4. We're going to do positive I times negative I. Positive times a negative is a negative. I times I is I squared. Okay? Now, once you get here, I know you're like, oh, there's so much on the paper. Relax. Look at it closely. You got rid of all the multiplying. There's no more parentheses. So it's adding and subtracting, which means you need things that are alike. So let's start up here in the numerator. What's alike we can put together? Oh, these terms. So we're going to leave the 4. Negative 2i plus 6i is positive 4i. Minus 3i squared. We're going to leave the minus 3. But wait a minute. What do we learn about I squared? Very good. We're going to put a negative 1 in that spot. And because they're side by side, they're connected by multiplication. Everybody with me? Now we're not done in the numerator. Now we can multiply this. So in the numerator we have 4 plus 4i, and a negative times a negative is a positive 3. Wait a minute. Now we got a whole number and a whole number. We can put these together. So in the numerator, 4 plus 3 is 7 plus 4i. And that's as far as we can go in the numerator. Now we're going to do the denominator. In the denominator, we have 4. We have a minus. There's the I squared again. The I squared stands for negative 1. Well, 4 minus negative 1 is really 4 plus 1, which now makes my denominator a 5. So that was the goal. The whole goal was to take this denominator that had an imaginary number I and make it a real number. Because this makes sense. I in life can divide something into 5 pieces. But unfortunately, we can't leave the answer like that because it's not written in A plus BI form. To write a complex number, I need to see the real part and then the imaginary. No sweat. This means divide by 5. We're dividing both of these by 5. So 7 over 5 would be the real part. That's a real number. It's a fraction. Plus 4 divided by 5 is 4/5 with the I behind it. And that would be your answer as a complex number, an imaginary part and a real part. So what we learned today is we went over all the rules of imaginaries. We learned in the first module how we even get an imaginary number. It's a square root of a negative. Now we learned once they're imaginary, we can do all these operations. This is going to be very important now when we go to module 4. Because when we get to module 4, we're going to be working some new equations. And I hate to tell you this, but let me give you a preview. The answers when you solve equations don't always have to be real numbers. They can also be imaginary. So when I catch you all in module 4, we're going to put this all together. We're going to solve a new equation and we're going to see some imaginary answers. I'll see you later.